In these problems, we're given the algebraic representation of a function and transformations to apply to that function. We are asked to find the equation of the final transformed graph. In the first case, we have f of x equals the cubed root of x. So this is our y. And we are to find the function that will shift the cube root of x 2 units to the right. So we have to substitute x minus 2 for x. So the equation will be y equals f of x minus 2, which will be the cubed root of x minus 2. Notice that we have a composition here. If h of x equaled x minus 2, this y would be f of h of x. Substituting x minus 2 into f of x is the same as applying the function f to the function that subtracts 2 from anything. In the second example, we start with f of x equals x squared. We're to move it 5 units to the left, and then reflect it over the y-axis. So we have to substitute x plus 5 for x. If h of x is x plus 5, we'll be looking at f of h of x, and that will give us y equals f of x plus 5, which this time is x plus 5 squared. Now the next thing that we want to do is to reflect the graph over the x-axis. That means we need to multiply all of the values of f of x plus 5 by -1. In terms of functions, if we let g of x be the function that multiplies its input by -1 or takes the opposite of its input, then g of f of h of x would equal the y we're looking for, which is going to be the opposite of f of x plus 5, or minus x plus 5 squared. So this is the expression for the final formed graph. We have one last example where we're given functions for f and g, and we are asked to find the formula for g, having been given that the formula for f is x squared. So we're starting with f of x equal x squared. If we reflect f of x over the x-axis, we will get an intermediate function that then can be moved 3 to the left and up 1. When we move it 3 to the left, the vertex would be at -3, 0. We'd have it going through -4, -1, -2, -1, and -1, -4, as well as -5, -4. That would be our second transformation. Then we could move up 1, and we would have the final function. So let's see if we can find the equations of the two intermediate functions as well as the final. So to do the reflection, we're going to take the opposite of f of x. It's going to multiply each of the y values in y equals x squared by -1. So each of the y values becomes the opposite of x squared. So this was reflect over x-axis. We're then going to move it left 3, which means we're going to substitute x plus 3 for x. This is going to give us the opposite of x plus 3 squared. We're now going to move it up 1, which means we're going to add 1 to the opposite of f of x plus 3, which will give us -x plus 3 squared plus 1, or 1 minus the quantity x plus 3 squared. Either of those last two would be correct. Now notice it would not have worked to move the function so that its vertex was correct before doing the reflection. Because if we moved the function, the original f of x, over so that its vertex was correct to start with, and then we reflected, the curve would go down here, and that would not be correct. So this idea would not work.